Thanks, everybody, and welcome to today's webinar. We are delighted to have you join us for the official launch of Breeding Resource, new drone-based image analysis service, a transformative step toward advancing high-throughput phenotyping applications across breeding programs. This innovative service leverages advanced image analytics to deliver precise, scalable, and cost-efficient data for crop performance evaluation. By integrating this service within the breeding research service, we aim to empower breeding teams and research partners with actionable insights, accelerate genetic gains, and support data-driven decisions making. Today's session will guide you through the key features of our new service, along with the testimonials from IRI and CIMI teams who have already benefited from the image analysis solutions. We are excited to showcase how the service can strengthen your breeding operations and enhance precision, efficiency, and data quality across the entire research pipeline. Thank you for being here. Let's begin this session by introducing our speaker and diving into the potential of drone-based image analysis in modern breeding. It's my pleasure to introduce our first speaker, Dr. Mark Guerra, the incoming director of the Breeding for Tomorrow Science Program. Dr. Guerra brings nearly 15 years of experience in the seed industry with a strong background in quantitative genetics, predictive breeding, and innovation strategy. Before joining us, he held leadership roles at Down AgroScience and Corteva, where he advanced genomic selection and breeding system optimization across global pipelines. Please join me in welcome Dr. Mark Guerra to open today's webinar. Thank you, Dr. Mark, for your insightful introduction. You can start.
Yep. Thank you, Vinicius. So hello, everyone. Thank you for joining. So it is a pleasure for me to bring forward these opportunities that we have in looking at digital phenotyping and how it aligns with Breeding for Tomorrow strategy. I look forward to, as Vinicius mentioned, I'm 1 month on the job, so I'm looking forward to meeting everyone and to work with everybody in this space. But yeah, Vinicius, feel free to just keep going. That's fine. And so how does phenotyping play into the strategy from a breeding perspective? I'm going to start with, I think, what is tattooed on everybody's eyelids when you close them as far as breeders. It is the breeder's equation. And so when when we're sleeping, we see this all the time. I have it tattooed on my eyelids. I'm just kidding, but we think about how do we increase genetic gain. This is what we're trying to work on. And throughout the genetic gain equation, we worry about the accuracy. So everything that we're working from a perspective of moving forward with breeding has to deal with the accuracy. It has to deal with the intensity at which we can make our selections, the variance that we're generating, and also how fast can we recycle. So all of these components come and play into the genetic gain equation. There's one thing that I also like to tack on top of this. All of this comes at a cost. So we need to really think about optimizing our breeding programs. Can we just go back and stay on that one, please? So we need to think about the function of genetic gain, but also the function of the genetic gain with relationship to cost. And so while we're trying to improve accuracy, we want to reduce cycle time. The cost comes in where we want to do more with the same or less resources as we leverage technology to fit into the budget. So how can we get better at optimizing that equation? And optimizing that equation comes in by optimizing all of the components of the equation. Well, there is technology that we can use to reduce cycle time. Reducing cycle time comes in from some technology like genotyping, for example, but it's also coming at the leveraging technology for improved phenotyping. Improved phenotyping actually has also an impact on the accuracy at which we are able to make that advancement. It comes at the benefit of also the more accurate genetic variance. And so that's the data quality. All of these play together in our ability to also increase the intensity of selection. So all of this is coming down to the point that if we can measure a phenotype in a more accurate way, in a more consistent way, it allows us to actually make better genetic gain at less cost, especially if it's coming in at a cost advantage. So with that, if we turn it over to the next slide, how these all come together. In the recent years, over the past probably 10, 15 years, we're seeing a lot more image analyses that are coming into the components. So what we used to be doing scoring from a manual perspective, we have now the ability to go through drone-based images or image analyses that allow us to actually take and capture that information in a faster way, less costly way, and also more standardized way. And so there's a lot of benefits that we can get out of some of these image analyses components as we standardize the processes. It is faster, it is less costly than manual scoring. And I don't know about you, but I've been into fields where it's like, 35 degrees Celsius, very humid outside. It's not a safe environment for us to be operating in. And so it's also coming in at an advantage of safety, not necessarily being out in the field in high temperature index to take those measurements. It is allowing for better logistics if you deploy the fleet of drones if you have, but also fewer errors because as you can imagine, as I was just talking about the walking out the fields in the heat, you start off very enthusiastic, and maybe halfway through, you're like, okay, I just want to get done with this. The drone doesn't care. The drone is flying, it's taking the image. It can actually fly over an entire location much faster and much more efficiently than an individual can do that. And then it delivers consistent high resolution measures. Those are also can be translated not only into scoring. So manual scorings are categorical as an example, 1, 2, 3, 4, 5, 6. You can attribute those drone-based image and annotate them as such, but you can also translate those into more of fields that are more normally distributed type of features. That gives a different perspective of how we can also make improvements. So there's a lot of strategic benefits from leveraging image analysis, drone-based image analysis, again, from the flight perspective as an example, to harmonize data collection, to actually bring in that data into enterprise breeding system that runs the analytics, but also scale that phenotyping, and the capacity for scaling. So the leveraging of image analysis, leveraging of drones in the data collection, it is actually part of our strategy to modernize the breeding operations by actually using the digital capture of the imagery, but also using shared digital tools that we have been working on building over the past few years. So if you can move to the next slide. So what does that mean as we're going into breeding centers and for B4T? So by leveraging the image analyses, by leveraging drones, this actually drives us as a whole, as a cohesive group, to get better quality data, harmonize data, but also lower the cost, the operating cost of us for collecting that data. It allows us to improve the confidence and also compare the measures, be it for the same crop across different sites and centers, so standardization, as well as improve the confidence across crops themselves and across sites. There's a collective benefit for all of us to work together to actually have shared services that allow us to reduce duplication and, more importantly, to reduce operating cost. So if you think about it this way, the economy of scale allows us to get better bargaining power and better bang for our buck. And then it actually, as I mentioned earlier, it does fit into the strategic fit that we have where we want to push towards transitioning towards the harmonized data collection within the enterprise breeding systems and actually translate B4T innovation into operational tools. So with that, I turn it over to, I think I turn it over to the next speaker. Thank you for your attention.
Thank you, Dr. Mac. Now it's my pleasure to welcome Gustavo Teixeira, the Global Shared Service Lead at Breeding Resource, who will talk us through the details of the new drone-based image analysis service. Gustavo?
Thanks, Vinicius. Can you hear me okay?
Yes,
Okay,
we do.
yeah, thanks. Okay, yeah. So some of you may remember a few years ago we had all the CG breeding programs. We went through an exercise to do improvement plans, and I remember that time we start talking about implementing image analysis or digital phenotyping. And some breeders discussing, hey, are we ready to start adopting that or not? And some discussions like, oh, but we still don't have the breeding software. We still don't have the support for analytics. Our operational capacity was limited. We don't have SOPs, or we don't have operational support. So and how to deal with that, with all those admin burden to hire a company. So many concerns and to how to start. And then, can you go to the next slide, please, Vinicius? So many things have changed. So now we have the EBS. Now we have the BioFlow, the analytic tool to help. Many improvements, mainly not only for that, but crop strand hunger help a lot. Many research stations, particularly in Africa, to improve their operation. We all know that now we have the operational support provided by Breeding Resource. Just go to the Service Request Portal and request the support, operational support. Our team has been providing this support. You can find many SOPs also in the Breeding Resource Portal. So many things that before we could see that as a constraint, that now we don't have that as a barrier now. So things change. So I think that now we can do it to the next step. So but how? How can we take this step to really deploy and adopt that as a routine in our breeding programs? There are many phenotyping tools from phones, satellites, or rovers, drones. So we had to start with something. So how to start? So that I put here some assumptions for why we selected this phenotyping that we'll present today as a service to facilitate the adoption of new tools. No? There's no one single tool that will work for everyone or in every situation. So we can think in many different tools for different situations. So there's no one that will fit for all. Many tools are being developed, meaning that will never be 100% ready. So there are many things, new things coming. So it's better to start and then we learn and then we improve. No? But of course, we need to start with something that is operational and ready to use. We had to find a solution that could cover more crops, and by doing so, like create a greater impact. We need to move from research to really the routine adoption. And we would like to start these because we believe that, as Max said, the phenotyping is part of this transition, and in terms of adoption of new tools and the digital tools, things will come more and more. We need to start faster now because it's a learning curve. We need to bring more people to participate in this process. Those people will also help to implement and deploy more of those things. Next slide, please, Vinicius. So that's why we decide to work in this drone space. Basically, the process will be like the local team, operational teams, breeding teams collecting the drone or the imagery using drones, and the scope of the service that we understood that was a gap, and the scope that could be served as a service is the image analysis process. So data from EBS and data later coming from this image analysis platform to support the EBS or to feed EBS and BioFlow is what we are focusing on. So this image analysis is the area in the boundary of this service. So with that, next slide, please, Vinicius. We hired Hiphen, that is the service provider that will provide the service. So with that, I will hand over to Lee, that is the business development director from Hiphen to explain this service.
Excellent. Well, thank you guys. I'm going to share my screen here and hopefully that will work seamlessly. Let's see how this works here. Yeah, slide 3. Okay, can you see my slide here?
Yes, we can. Go
Image
ahead, Lee.
acquisition vectors.
Yes.
Okay. All right, we'll start here. So again, thank you, Gustavo and Vinicius, for the opportunity to talk about imaging systems with you guys here today, specifically drones and how they can affect crop breeding. Mac did an excellent job of kind of describing where this fits into the breeder's equation as you fill your pipeline with information that allows you to make better decisions, faster and ultimately improve genetic gain. My name is Lee West, and I am the Business Development Director at Hiphen. At Hiphen, we're focused on developing tools that help researchers tackle the challenges of 21st century agriculture, which is really what all of the associated members of CGIAR are engaged in. And so, these tools, image analysis tools, are rapidly becoming domain standards in the crop research and breeding communities. And so we're excited to be making them accessible to more CGIAR associates around the world. I'm going to frame this discussion around three pillars of image analytics. And ultimately, the things that you have to do, you have to acquire the images, which is sometimes challenging. Trait extraction, which is once you have the images, processing them, stitching them together, pulling information out of them. And also data visualization, image query, and data science. This is, now that we have all this new information, how do we start pulling it into databases like EBS, but also how do we use the images themselves as tools to get more information about our programs. So I'll start really briefly. I won't go into details on this, but I want to start by mentioning the 6 dimensions of phenotyping. This framework helps us think through the options for sensors and vectors to carry and orient the sensors. Yeah, I won't go too much into this, but if we're building systems kind of like what Matthew Reynolds has in Obregon, where he has a phenotyping cart, where he has to orient the sensors in the right way, and each sensor will be different. He's often going through a process like this, and so we have a principled way of approaching processes. And of course, drones are capturing, spectral images, spectral. Let me get back to that here. So as we look at, we work with any image acquisition vector, including greenhouse and lab scale phenotyping systems. And I won't talk about those, but I want to briefly touch on several field imaging systems, including some that are alternatives or complements to drone imaging systems. I'll start by touching on the 3 main vectors to carry these sensors to the field, which are, of course, drones, Literal, which is basically a manual system to carry a sensor to the field, and I'll show you that in a second. Phenomobiles, which are tractor-mounted sensor arrays. We have one of our sensor arrays at the ICARTA site. And we also have satellite imagery, which we pull down. And we've talked about this with some people in Africa who maybe have difficulty getting to sites. And we have a project with ERS where we're trying to, or Schultheis, to try to get to look at satellites as research tools. But we do a lot of work with satellites for production fields. And so I want to just mention these things because they each have their strengths and weaknesses when we're looking at capturing spatial, spectral, and temporal data from fields. Drones, obviously, the most efficient way to get across the field quickly, and where there are thousands of plots, that's generally the vector of choice. But we also have ground imaging systems, and because they're so close to the canopy, you can see that you get really high spatial resolution here, down to 0.36 millimeters, which allows you to start looking at things like yellow rust on wheat, fusarium head blight on wheat, and other things that are very small and need a lot of resolution to quantify. And with a tractor-mounted sensor array, you get even more resolution because you can carry heavier sensors and you can, move consistently through a field, so it's higher throughput. And you can carry, because you've got a tractor framework, you can carry multiple sensors at once. But again, we're going to focus on drones, but I do want to talk a little bit about how we often are fusing this data. So we use these other systems in conjunction with drones quite a bit, where we'll fly maybe a wheat field, let's say wheat research field, where we're flying a drone for the season to look at plant height, NDVI, vegetative indices. But we also use a littoral at certain point, or a handheld system to get more granular resolution traits like wheat head counts. We also work some with satellites where we're looking at fields, particularly where we have things like irrigation blocks, where you're doing some agronomic practices in different irrigation blocks, and we often are using satellites for that type of work. Once we figure out how we're going to capture the images, we start, then the next step is to process them. And what we offer here is, there's a lot of open source tools, and people have kind of put together systems and to process imagery from drones. But we kind of add an extra layer of sort of the Hiphen, I call it the Hiphen experience, where we're trying to reduce friction for researchers. So it can be very challenging. A lot of times people who are doing this kind of work themselves often will take at the end of a season, they'll fly drones at the end of the season. They'll take a few months to process that imagery and extract traits. And, you end up getting the data many months after a field season is over. We try to condense that, so we're delivering data after each flight. And, usually we're somewhere between 7 and 10 days to deliver that data. We can deliver it even faster if necessary. And the way that we can do that is we have a dedicated team of image solution specialists that will guide this journey. And so what we do with new people who are new to drone imaging, because we often work with people who are flying for the first time. We also work with people who have flown for, several years and just want to be able to extract that data in a more efficient way. But we always start with a welcome aboard type of meeting, where we set expectations on timing. We learn about the equipment that you have, and we can then customize protocols for your specific equipment. We'll identify any knowledge gaps that we have to run an efficient program, which could be things like can you lay ground control points? If you want things like plant height or biovolume, that would be the way we do it. Sometimes that's not possible, so we kind of can work on alternatives. And that's what we usually assess in a kickoff meeting. And, there we'll introduce a project manager. So what each project will have is somebody from the Hiphen team that will be involved. They'll describe the project management process, get details about the crops that you're looking for, what phenological stages are important for you to collect data, and then give a taste of what you'll get, and then what you could get with even more protocols and more detailed missions. And then what we do, we have some sort of communication cadence through the season, and that would depend on the crop, what the targets of the crop are, but we'll stay with you through that process. So after you upload a first image set, we'll have a meeting with you to make sure that the plot maps look good. We'll put the plot maps on there. We'll make sure they look good, and then start extracting traits. And then at the end of the season, we usually have a capstone report where we're looking at what went well. We assess the scale of the project, and we also identify areas where we could make improvements towards next season.
Sorry, Lee, you need to fly. You have 3 minutes.
Okay, no problem. So what we have here is we have some custom, some core recommendations for each crop. And the way that we build these recommendations, and we build sort of detailed protocols, is we're actually looking at what your equipment is, what the object size is, what required resolution we need for that, and then we can calculate the altitude and ultimately build detailed protocols. And I want to touch really quickly on just sort of a range of traits that we have here for the different crops. And then oh, shoot, I didn't move the screen here. Sorry. Here's a range of traits that we have for different crops. What we're going to do eventually is we're going to meet with individual research teams. So this is an overview of the traits that are available, but when we have a meeting with an individual team, we'll have a breakout that'll just look at the traits that are available for, let's say, maize, and things like that. So it sounds like I've taken a lot of time. What I would also like to do at some point, if you can still see my screen, do you see a world map here?
Yes, we do.
Okay, I'm just going to go really quickly through. This is kind of projects that we're working on all around the globe. If we go into here, this is the experience that you'll get. You'll see your project on a map, and you can kind of zoom in here, click on any plot, and you can look at the history of that plot from here. We're doing stand counts all the way to here where we're assessing, we're counting sunflower heads. Here we're assessing what phenological stage you have at this to look at the flowering dynamics of different varieties. I think that's really what I wanted to touch on. You know, we will help walk you through this whole process and help you get this imagery and then analyze it. And I don't really have time to go into the analytics tools, but we have some analytics tools in here that we also will walk you through in that Hiphen experience journey.
You can just show very quickly the analytics
Okay.
screen,
So
Lee. You have 1 minute.
Okay. I'll look at with this analytics tool. Let's see. So we're looking here where we can now go into a date and we can see all of the traits that we calculated with that flight. And if we want to look at green cover, let's say we can look in, we can start to see the green cover dynamics through time for this set of this was actually this wasn't a breeding trial. This was a crop protection trial, but you can, if you had a bunch of different varieties, you would see how the dynamics played out over time. We can also go into specific varieties and look at them at high resolution. We can look at if you've got replicates, we can look at all the replicates. We can scroll through the replicates. We also have I think I've got this open here. Yeah, we have in our analytics diversity mapping, we're using this often for things like disease resistance. This is a disease resistance trial where we're trying to basically use cluster analysis to go, hey, here's a plot that seems to be very different from this plot, and what is that difference? And I could scroll through the time series and see that you have this plot is very disease susceptible and this plot is very disease resistant. And then what I would normally do is look at this set of plots, these varieties that seem to be disease resistant, and that now I've narrowed down my target populations that I want to advance from 1,200 to 200. So these are tools to help you kind of guide you in making some advancement decisions and identify varieties that might cluster together. And there's a whole bunch of
Thank you, Lee,
features
for
I
the
don't have the
insight.
time to go through.
Yeah, unfortunately, but we're going to have
Thanks,
the
Vinicius.
opportunity to have a one-on-one meeting. Thank you, Lee, for the insight presentation. Now let's hear from Princess de la Cruz. She's the breeding operation manager at Erie, who will share her team's experience and testimonial on using the drone-based image analysis service to enhance efficient and data quality in their phenotyping activities. Sess.
Yeah, thank you, Vinicius. Can you hear me?
Yes, we can.
Yep.
Okay, thank you very much. So we did high-throughput phenotyping using the drone way back March 2024 to December 2024. So the breeding operations unit on my side, we did the logistics on the drone operations, while Hiphen did the image analysis, while breeding analytics unit under the breeding resource did the analytical machinery. Next slide. So basically what we did, we have the Erie breeders have their plots layout in the field, and we did a series of flights using the drone and captured the data. And then we sent the data to Hiphen. Next slide. So these are the fields from them. So looking at the time series data averaging for each trait, we can see that there's high correlation using the high throughput data. So instead of doing the manual, you can see there's a high correlation. So this can serve as a surrogate or a replacement for doing the manual phenotyping. Next slide. So here we can see the quality of the high throughput traits is good, as highlighted in the red box. So we normally measure the quality of the traits using the reliability, which is how much genetic signal really exists in the phenotypes. So the signal usually goes from 0 to 1. A trait like yield has normally a reliability of around 0.2. So reliability of a complex trait like yield is close to 0.2. Reliability for something intermediate is around 0.5, like maybe for flowering dates. So, and the reliability of highly heritable traits is around 0.7, and above, like plant height, is normally 0.8. So looking at this table, the fact that HTP traits are in this range from 0.5 to 0.8. So it means we are talking about medium to high heritability traits. So that allows genetic signals. So looking at the usage for this model for high throughput gives us high accuracy for better breeding decisions. That's all. Vinicius?
Thank you, Cez, for sharing those valuable insights. Next, we are pleased to welcome Dr. Matthew Reynolds from CIMMYT. Dr. Reynolds has extensive experience in advanced phenotyping strategies and applied data-driven approach to accelerate genetic gains. We kindly remind everyone, include Dr. Reynolds, that we keep this segment to around 5 minutes, and we are mindful of our schedule. Dr. Reynolds, the floor is yours.
Hello. I'll get straight on with 5 minutes to spare. With 5 minutes, I thought it was a little bit longer. Anyway, there's the title, and we can move on to the next slide. So just to put a bit of context to our pre-breeding, to our phenotyping rather, this is our pipeline for pre-breeding. And you've got crop design, looking for genetic resources, phenotyping in lots of different ways, but all of these, right through to evaluation of international nurseries, they all involve phenotype. So it's an absolutely pivotal area for us, and why we spent many years developing approaches. Next slide. I just want to make the point, though, this figure, I'm not going to go through it for interest of time, but you've essentially got two very different types of drought environment. And you can see from this that different traits are involved. Some of them are proved, some are theoretical, but the evidence comes when you sow the same material under the same different environments. You'll very often see no correlation whatsoever. So we always need to bear in mind the environment and not just be seduced by the relative ease of high throughput phenotyping. Next slide, please. And push it again. So our reader friends want friendly phenotyping tools. Press the advance. There's a bit of animation here. Just press so the text comes up. So there we go. The breeder's favorite tool is the low resolution stereoscopic spectral radiometer plus supercomputer, which already you can see is their eyes are low resolution stereoscopic spectroradiometers, and their brain is a supercomputer. And that tool will always be the most useful remote sensing or proximal sensing tool to most breeders, I suspect, because there's so much to look at that you want to look at quickly. But you can't see temperature. No animal, I believe, can see temperature. And temperature is so tightly correlated with yield and with other things under stress in particular, that's a very valuable extension, if you like, to their eyes. Spectral reflectance, same thing. You've got high resolution, so now you're seeing not just a sea of green, but you're seeing the pigments that help with photoprotection, the reds, the greens, sorry, the reds, the blues, and purples that are photoprotective in nature. Next slide. So we started deploying drones from about 2012 in research and line selection and breeding. And by 2016, Jessica Rakowski was publishing how much added value to genomic selection you got by including just two relatively straightforward traits, canopy temperature and vegetative indices. And as Lee mentioned, there's a lot of traits we're interested in. Sometimes we use a buggy for payload advantages, and you can get more simultaneous measurements, which helps in interpreting, particularly in research. Next slide, please. And here we go with Hiphen. Not that one, next. That's it. And you can see the evolution since Francisco Pinto came in 2016. I'm not going to go through all this, but you can see a number of traits there, that an increasing number of traits, and of course different options. Drone, buggies are great for payload, but drones, if you want to study flooding, perfect instrument. So, there's horses for courses, or not just for traits, but also for how you go about it. But Hiphen can analyze anything you want. That's right, Lee, isn't it? Next slide. Okay, just, and hit it until the other features come up. Just a brief explanation. So Maria Tataris was able, could you advance? There's a couple of animations here. She was able to publish a comparison of field-based and drone images. And basic idea, multiply this number of plots by 1,000. First of all, you're able to measure things in the same environment. And when I say that, I mean not having to spend 3 hours between 11 a.m. and 2 p.m., during which the environment has changed, measuring something. Now you've got everything at once. Plus, you can go in being digital, make an analysis, remove those outlying points where maybe a duck's nest made a difference, or the irrigator's dog ran straight through your plot. Those kind of outliers make everything much more accurate, and the paper showed give a better association with yield or whatever performance trait you're looking for. Next slide. And here's a very, very interesting fact about measuring canopy temperature to predict roots. Here you can see an extremely high correlation between canopy temperature and root dry weight between 68 and 120 centimeters. It's actually a better prediction than actually, sorry about messing up the second. It's a better prediction than with yield, it should say at the bottom there. And I draw everyone's attention to the figure on the left. The largest confounding factor in controlled environments is studying roots in pots, because the temperature has nothing to do with their real-life temperature. We have to measure roots in situ, and we can do it with high-throughput phenotyping and good image analysis. Next slide. Nearly done. I think this is the last slide. It's just a sort of a summary of the potential. Phenomics is key to managing complex traits in breeding, and is also enabled by some new confluence of new technologies. As was mentioned, satellites turn our planet into a de facto laboratory if we choose to. Black boxes are opened, like root depth. Things that need to be in crop models and are not. And of course, with gene sequencing and more phenotyping, more routine phenotyping, we will understand bases and have markers much sooner. And we all assume and are already using, in some cases, AI to vastly accelerate the whole issue of analyzing multi-dimensional data. And I just saw our wiring diagram at the bottom, which is considered a prior for those kinds of exercises. And I think that was the last slide.
Thank you, Dr. Reynolds, for the excellent presentation. Now it's my turn. I'm Vinicius da Rocha. I'm the Global Breeding Operations Support Manager at the Breeding Resource. And let's take a look on how we can start to get the benefit of this innovative service. This basically is the workflow. So the user is going to open a request either in the CGIAR Service Request Portal or directly into the EBS if they are EBS users. Then we're gonna schedule a meeting to review together to define the scope, to see about the costs and capacity that need to be developed inside. The user is gonna be approval of this request, and then Hiphen gonna create the credentials and start the work with that. The user is gonna send us the images captured by drone, right? So for us to upload it in the Hiphen's platform, and so then the data process is gonna be done by Hiphen. As I told you before, to open this request, you have two possibilities, one in the Breeding Resource Portal and another one direct in the ABS platform. The Breeding Resource Portal is the same portal that you can use to obtain other kinds of help, since in engineering capacity, agronomic practice, and so on. Is access for the same website with the same login that you already have. You can sign up if you already have the login. Otherwise, you can create an account. It's open for everyone. You can scan the QR code and go direct to the website. And then it's the same following process. You create a request. You go for the request, you create a new request, and you put the phenotyping data accession through our portal. If you are EBS user, when you go to the service management, you're gonna see a new icon over there, digital phenotyping service, and then you create a new one, and then you just follow all the steps, so on. The EBS are gonna connect with all your trials and the service you're gonna be provided for you. Okay, I think some of you is curious about costs and timelines for that, so we just bring some example over here. So this is the package used for maize, for example, that the cost starts from $2,279. We exit all these traits, right, in the different time of the crop. So in the emergency, the cell cycle, and the kernel maturity, all these traits was covered in the different stage of the crop and the different time for the same orthophoto, right? We do have a difference from the first orthophoto of the season and the next one, let's say the next flights. The first orthophoto is a little bit more work demand. We need to reference all the plots and so on. And the size of the orthophoto could be up to 25 hectares. In this example, we analyzed 2,300 plots in the same photo. That means this price is less than $1 per plot, okay, for all these traits. The price is case by case. We need to analyze together the traits available, the crops, how many flights, how many orthophotos you want to analyze, and so on. But just for you to have an idea of the price, okay? Hiphen is compromised to analyze the data up to 20 days. Sometimes they even deliver fast, and if it has any emergency, we can push this time even shorter. Okay. After this, we're gonna schedule a one-on-one meeting for all of you, the breeding programs. We already start to schedule some of the meetings, so you can have all the information that you demand. If you have a demand right now, you can just reach us out right away. You don't need to wait for us to schedule the meeting, and we are more than helping to help you to start the digital analysis. Okay. Last but not least, I would like to say that at the same breeding portal, we have already uploaded the course, our Erlang platform. There is the CGIAR Hiphen tutorials over there, how you can access all the service. Everything is in on videos and Erlang, very easy to get it out. And as well, the BPM Unity already upload as well all the SOPs that you demand to fly your drone step by step, what you need to see and measure for you to have a protocol of the flights, okay? It's the same place that you can find other SOPs such as seed storage, shipping, and all the other planting, harvesting, and so on. That's common for all the CG system. Now I'd like to open for questions. I see that has some questions on the chat as well, but feel free to pop in and make your questions right now. I will just get the first one that I can see here from David Gonzalez. Maybe this, I don't know if Saz is still with us and she's operational, or maybe Alec as well that has experienced this. He's asking that you're gonna be good to show the heritability obtained with manual phenotyping and the heritability with the high-throughput phenotyping. Says, you wanna take this one? I think you compare this for your trials, right?
Yeah, Vinicius. We did
So
one.
David is at
Yeah. So we did one comparison with the manual. If you can go back to the graph that I have shown earlier.
right there.
Yeah, it's okay. So in terms of heritability, this only shows the correlations between manual phenotyping and high throughput traits. But the question is more on manual phenotyping, yeah, heritabilities compared to heritabilities with HTP.
Exactly. Did you compare this heritability from the manual of the high-throughput phenotyping? I
Yeah,
think maybe Reynolds as well has experience with that, if you can compare the
Yeah, I
results of the
mean, I can
heritability
say
using this
that
kind of thing.
heritability is improved, and you know that's understandable. You're reducing environmental variance by instantaneous imaging. You're able to clean plots by outlier analysis. You're bound to get higher heritability, and we did find that. And so, yeah, I mean, absolutely, this is, yeah, if you're very, very careful and use excellent designs, you can get it pretty good from proximal sensing. But, you know, you don't need to worry as much about your field layout when you can get instantaneous readings and clean up your image analysis. I mean, what do you do when there's a great big hole in your plot on the ground? There's not, and analog devices, not much. But, you know, with Hiphen, we opens up a lot of possibilities for rigor in the quality of the data.
Yeah.
Thank you. I'm gonna get a quick one. How big of the plots in the example? So we have a limitation up to 10,000 plots within the area of 25 hectares per photo, right? There's some things, some details that you could speak, but you could say the biggest area that you can go is up to 25 hectares, independent of the plots that is there.
Yeah. I
Uh,
will just say that we can handle and georeference all different size plots. So, you know, we have methods for measuring really large plots. If you have sort of like an irrigation block that is a plot, and it might be 20 hectares. We have ways of doing that. I think what we're mostly talking about with Vinicius are the small plots, and there we run into a sort of a limit of what we would call one ortho image, and then we'd have to have another site if it was bigger than that, which is perfectly doable.
Maybe on this matter as well, there's two similar questions. Do you have to use ground control points? And we don't need to to do photogrammetry process and to generate the auto mosaic using software like the Pix 4D before you upload to Hiphen?
No, we would take the raw images and we would do all of the processing. So you won't have to create the ortho image. We'll do that. If there's any problems with it, we'll visit with you. The GCPs we always recommend as a best practice. And there's several layers of doing that where you actually just put them out there. And if you're doing multiple flights through a season, the ground control points make it much easier to align the plot maps. If you get RTK precision on those GCPs, that allows you to do some advanced photogrammetry where you can create point clouds and have much more confidence in the point clouds. Yeah, so we can talk through GCP strategies.
Thanks, Lee.
And
I
even if
would
you
just
can't do
remind you that in
GCP, you
our
can still
SOP,
learn.
yeah, our SOPs, all these points are contemplated in the SOP, and it's very easy to read. You can download in your learning system. Lee, maybe for you again, FORADs are important traits of nutritional value as protein content. Do you have any expectation for this type of traits?
So protein content, we are working with different groups looking at what we would call phenomic prediction. This is kind of, I think Matthew maybe have alluded to this a little bit, where you measure traits that are not directly protein content, kind of like what he was talking about with the soil, but you can start to infer, from a different range of traits, what that protein content might look like. Kind of like what I showed you with the disease resistance. Some of those plots didn't even have disease in those plots, but because they were clustered with other plots or varieties that we knew that did show that resistance, we identify them as disease resistant. And it'd be the same thing with protein content. If you're really looking at protein content up close, the phenomic prediction works best where there's an allometric relationship between protein and some traits or set of traits that we're measuring. But even without that, we're looking at whether that's possible. With AI, it's kind of amazing some of the things that we can correlate.
Thank you, Lee. Lee, maybe can you share again just the traits so that people can have a better look on that?
Yeah.
In the meantime, I think this is for Gustavo. Gustavo, some of the questions here say that some of the CG centers has initiative on phenotyping, and the team from CIAT would like to know if there is an opportunity for them to be involved in the upcoming drone phenotype initiative. They are eager to collaborate and share insights from their ongoing work. At this stage, which traits can be accurate extract from the drone imagery? So, Gustavo.
Well, of course, the CIAT team, of course, this service is for everyone. No, and the point is if the Hiphen will have or not the traits for the crops that they are working with. So this is one thing of type of discussion that we need to have one by one, case by case, and sit together and understand. And if that what we can Hiphen can offer to them is what they need, definitely they can access. The service is available for everyone. The point is just to if that adds value or not for them. Okay, so CIAT team, please just contact us, and of course we'll be in touch with you as well, and let's work together. So that's definitely, as I mentioned before, it's a complementary solution for, and we know that CIAT, you have done a lot of work in phenotyping, a great job, and of course just here to help and to add even more value to what you have already done. No, yeah.
Yeah, and we know Michael and Salvaraj, who's done a lot of amazing work on this stuff too, and more than happy to work with him. He also can do some of this stuff, so we understand that there's some overlap there.
So Lee, because you talk again, I'm gonna give you another question. They're asking if there is artificial intelligence models being used in your system, right? And if there is a minimal plot size requirement and the distance between the plot for drone data.
Okay, so there's a couple questions there. So minimum plot size, no, we can work with individual plants, that are often, I don't know, maybe, I don't know, a quarter of a meter by a quarter of a meter. I've seen even smaller than that. It's just, we that requires a discussion. The distance between plots, not a problem as long as we know what that is, and we can lay the plot maps on top of those. And then in reference to AI, yes, when we do counting and classification modules, things like weed head counting, there is some AI that is involved. We tend to try to work with more traditional machine learning on the front end. It's more reliable, more traceable what actually is going on. However, we do use quite a bit of AI to expand the trait capacity that we have.
Okay,
I'd just like to, if I may, come in a little bit on plot size. It's something one has to pay quite a bit of attention to, because if you go too small, and depending on the trait, if it's a trait like canopy temperature interacting with the atmosphere, you may end up with just edge effects. If you have big alleys, you confound, because some genotypes are better at taking advantage of the space, both underground and above ground. So you need to, whereas something like NDVI, you want a measurement of early vigor, true, you can go to almost any plot size. So, one must consider what is the physical basis of the signal that you're measuring when you decide, and of course the interactions that are possible underground before you make a decision on plot size, I would argue.
Thank you for that point. You don't want to introduce artifacts that Matthew is. So I was just thinking from the imaging standpoint, we can kind of work with and mask things. But yes, that's a really good point. You don't want to have a plot that's too small where your edge effects become bigger than your true signal.
Great. We are coming to the end. There is asking about which kind of drone you are using. So this the drone that the CG centers are capturing the images is usually a DJI Maverick Pro. So it's not a rocket science. It's available everywhere in the road. All of these details is in the SOP. And I would like that Gustavo give us the final remarks.
Okay, thanks, Vinicius. Thanks, Lee, Matthew, Sess, Mac left. Of course, although I know and we know that there are many questions and doubts, but as I said as well, is it just a starting point? We will connect with all breeding programs. So the questions that we receive, we will try our best to respond and contact the people that made the questions to respond then. Anyway, so this is a starting point as well, as I mentioned. So we will, from now on, connect with all of you, breeding programs mainly, but anytime if you have any or desire to initiate this work, or you want to learn a little bit more, please contact us, and then we will decide together what would be the best approach in your case. And hopefully this will help to improve the data, have better or insights, and as Max said, help all the CG breeding programs to speed up the variety development with better products. So thank you so much. Thanks everyone that joined us today, and let's stay connected.
Thanks, everybody.
Thanks, Gustavo. Thanks, Lee. Thanks, Reynolds, Sess, everybody to join us. See you in the next time.
Thank you, everyone.